All right, let's keep talking about section 7.1 about quadratic functions. So let's take a look at one in which we have an a value. Again, the formula in vertex form is a times x minus h squared plus k. We call this vertex form because it gives us the vertex. We can visualize the vertex. Again, you are asked to find these 8 pieces. So, part A, does the graph open up or down? It opens up. And again, that's because it's positive. So it opens up. Got a little frog paperweight now. What is the vertex? The A value does not affect the vertex. The vertex is just at HK. So instead of a -1, the vertex is at a +1, and then whatever we see here. Next is the x-intercept. We can change y to 0 and all that. But frankly, on a problem like this, we can always graph these as well. So 3 times x minus 1 squared minus 3. And it looks like we're at 0 and 2. A couple things to point out. I do like the way Professor Steele changes the window so that if you hit trace and move the cursor, you hit good values. See, it's going to move past the 2 because I haven't changed my window the way that he pointed out. So that is a very cool way to think about trace. The other way to think about trace is we can type the x values we want to evaluate. So I hit trace, and then I type 2, and that popped up, and I hit enter. And sure enough, 2 is an x-intercept. If y is 0, then we are an intercept. And then at 0, 0, 0, where that's another intercept. Of course, you could go to the table, and wherever y is 0 is an x-intercept. Or you could change y to 0 and solve it algebraically, which, it's easier to do it this way. Part D asks for the y-intercept. Now, that wouldn't be too hard to evaluate here. If we're on the y-axis, change x to 0, and then you just do a little bit of math over here to simplify. But it would end up canceling itself out. 0 minus 1 is -1. -1 squared is +1. 3 times 1 is 3. 3 minus 3 is 0. But we also can see that when x is 0, y is 0. So our y-intercept, it hits the y-axis at the origin. So, of course, you make these ordered pairs. To sketch the graph in ALEX, you just plot the vertex at 1, -3, and another point. You would probably do 0, 0. That's an easy one. Again, just pick up the parabola tool. Again, an a value that is greater than 1 will make it a kind of a skinny graph. It stretches it vertically. Next is our axis of symmetry, which is easy because that's just x equals 1. The x value of our vertex. Then we find our max and min. We open upwards, so we have a minimum value, and then we state what that minimum value is. It's just the y value of our vertex, -3. So a minimum at -3, because the vertex is at 1, -3. And part H, for the domain and range, domain is always negative to positive infinity when talking about parabolas. And then the range, we have a minimum, so it's the minimum value with a bracket opening up towards infinity. So -3 to infinity for the range. So there's another example, like number 2. I believe number 3 is similar. Number 4 is probably the one that students are going to have some trouble with, because now we start in standard form or polynomial form. Doesn't matter what we call it, because here this doesn't give us the vertex like the vertex form. We cannot just look at the equation, change the sign of h, identify the k value. Here, when we're in standard form or polynomial form, this is where the vertex is at negative b, oh boy, over 2a for the x value of the vertex. And then for the y value, we plug this in. Plug it in to x and solve for y. But I'll be honest, students just have trouble with this, and that's okay. All we really need to understand is that the x value is negative b over 2a. And then we're just going to use the calculator. So, again, same questions. This opens up because the x squared is positive. It doesn't matter if any of the other signs are negative. It's just the leading term. And you're not really given these out of order, the problems that you're going to see, I don't think. So next is the vertex. So let's find negative b over 2a for the x value. B is 10, c is 1. I'm sorry, a is 1. So negative 10 over 2 times 1 is negative 5. What I want you to understand is that the x value of the vertex is negative 5. Because if you can find that, then we can find everything else in the calculator. I'll move this in a second. x squared plus 10x plus 9. So we can't really see the vertex right now. We could change the window so that we could look further down. But again, I like this trace feature when I hit trace and then type in a value like -5. If I hit -5 and enter, this will just give us the y value of the vertex. Again, we could plug in -5 into x squared plus 10x plus 9. And that would be 25 minus 50 plus 9. And that would come out to -16. Or we can just find the x value using -b over 2a. And we could even go to the table. And you see, if we look at it at the table, if you're a table kind of person, let's look at this for a second. At -16, at -5, -16 as an ordered pair, it starts to mirror itself. That makes the parabola shape, the U shape. So this is our vertex, even if we can't see it and you don't want to change the window. But here it's not down far enough. If I make that 20, now we see our parabola. I can hit trace, type -5 and hit enter. And again, we see that's the vertex. So the vertex is at -5, -16. And again, we can look at the graph. To solve for the x-intercepts, we would make y equal to 0, and then we're just solving this quadratic. We could factor it. That would be x plus 9 times x plus 1. And when we set those equal to 0, we get x equals -1 and x equals -9. So those are the x-intercepts. It's really easy to find the y-intercept in standard form because all we have to do is change the x's to zeros. So the x term 0 out, and we get 9. Or again, if I hit trace, if I hit that x is 0, that would give us the y-intercept, because when we're on the y-axis, x is equal to 0. If I went to the table, this is another way we can spot the y-intercept. We should know that if x is 0, we are on the y-axis. So 0, 9 for the y-intercept. Again, you know how to do the sketch. Axis of symmetry is just x equals the x value of your vertex. Minimum and maximum, again, our vertex is at -5, -16. So we have a minimum value at -16. And then the range will be -16 with a bracket up to infinity. So minimum value at -16. Domain is always negative to positive infinity, but the range is the minimum value, and we're opening upwards, so towards infinity. Number 6 is similar to this. You could just use the calculator. Number 5, I have an example here. We are just asked for the vertex. So again, in polynomial form or standard form, the vertex is at -b/2a, and then the y value at that x value. Or take that x value, plug it into this equation, solve for y. But again, it's easy to find the x value of the vertex because that's just -b/2a. That's really important, so know how to do that. So here, -32 divided by 2 times 4. That's 32/8, which is 4. So we found that the x value is 4. We just need the y value. And again, I would just use the calculator. So 4x squared minus 32x plus 46. There's the graph. Again, my window was, I changed the minimum to -20 so we could see the vertex go all the way down. So we'll use that. If I hit trace and 4 and hit enter, maybe a little hard to see because the vertex is kind of on top of the 8 there, but that is the vertex. Actually, I can't see what that number is, so let's go to the table. When x is 4, y is -18. And again, you can see at the vertex, the points become a mirror. So 4, -18 is the vertex. That's the way I would recommend solving these problems. So I think that answers everything for 7.1. If you have any questions, let me know.